Hello students, today we are in lecture number 18 of standard 11th. We are studying here the vector. Hopefully it is the last class of the vector analysis. So my dear student, we have studied the dot product and cross product of two vectors, how we'll do the dot product and cross product. We have studied the application of dot product. Here today, in today's lecture, we'll study the application of cross product, how we'll do the cross product of two vectors. Okay, my dear student, here the one question, we will start with the one question. It is try to find the answer one, and when I remember, my dear students, the one question I have been asked, what will be the answer of A dot A cross B, that I have been asked in last class. A dot A cross B. I have been asked this question in last lecture. The number of students have given the answer. Let me tell you the answer of this question, my dear students. Here, A cross B, suppose we are having a vector A like this way and the vector B. Okay, this is the angle theta of A and B. Now, try to find out A cross B first. A cross B. Alright. So A cross B will be perpendicular to the plane of these two vector. Of course, if this is the plane of this two vector, so the A cross B will be in this direction. Alright. Here we will write A cross B. A cross B. It is AB sine theta n cap. And this will be the direction of n cap, A cross B. Here the n cap, it is quite obvious, n cap is perpendicular. It is n cap is the perpendicular. Alright, perpendicular to which vector, A or B? Answer is both A and B. Alright, n cap will be perpendicular to both A and B. N cap, it means the AB sine theta. Alright, AB sine theta, that is the result of A cross B, is perpendicular to both A and B. Now, if you are doing A dot, what you have to multiply here, the AB sine theta, alright, with n cap. Now, if this A and n cap are the perpendicular to each other, then what will happen? You will find a magnitude here, the A square, this is A square B sine theta, and the dot product of two vector which is at right angle, so the cosine of 90. Alright, and what will be the cosine of 90? It is the 0, entire will be 0. So A dot A cross B will be 0. Directly you can think, my dear students, if this n is perpendicular to both A and B, here the A and B are coplanar vector, then the answer must be 0. Alright. Now, if you ask to think upon this type of question, my dear students, you have to prove the three vectors are given. Alright, A, B and C. Alright, A, B, C are given. And you have been asked to prove, how will you prove that three vectors are coplanar? How will you prove that three vectors A, B and C are coplanar? Then how you will prove? So if these three are coplanar, remember, then again the same case. This will be the applicable for the coplanar vector. If these three are coplanar, of course, thus A cross B, the cross product of any of two vector, all the three are coplanar, then cross product of any of two vector must be perpendicular. It should be the perpendicular to the third vector. Alright, the result of A cross B will be perpendicular to third vector. In this case, A cross B dot C must be 0. So this is the condition of coplanarity. Okay, coplanarity condition will be, if three vectors are coplanar, then cross product of two vector will be, and dot of the third one must be equals to how much? It is 0. This is the condition of coplanarity. And this type of question you will be asked in you have been asked in SC Burma book. Okay, you can solve here today. In today's lecture, my dear students, we are going to study the application of cross product. All right, so let's begin with the application of cross product. The first application we'll study finding angle between two vectors. All right, okay, let me rub this. So give the heading, my dear students. The first application is the angle between two vectors. Although we have studied how to find the angle between two vectors using the dot product, okay, but here using the cross product we are going to find the angle between two vectors. The first application, it is finding angle between two vectors. All right, yes. Angle between two vectors, my dear students, we know that if there's a two vectors A and B like this way, this is the vector A and this is the vector B inclined at an angle theta, then we know that A cross B can be written as A B sine theta n cap. All right, and mod of A cross B will be what? It will be mod of AB sine theta n cap. This is mod of A cross B. All right, and this AB sine theta mod of n will be, see, the AB sine theta and mod of n will be how much? It is 1. It means sine theta you can find out by A cross B divided by AB. Okay, so by doing cross product of this two vector and dividing the product of magnitude of two vectors, you can find the angle between that two vector. The theta will be sine inverse mod of A cross B divided by AB. But you know very well that you can realize this method is a little bit time taking compared to the dot product. Using dot product you can find angle easily, but if you have been asked to find the angle using this cross product, then you can use in this way. All right, the second example. All right, finding area of triangle. Finding area of triangle. All right, area of triangle. Let me draw here the triangle using two vector. If I have been drawn, okay, the two vectors I have been given A and B. In question you have been given two vectors which forms triangle. We know that to form triangle we need two vectors. Third vector automatically will be the resultant one, okay, or the closing side, and you have to find the area of this triangle. We know that the area of triangle in geometry we have studied in mathematics. If this is the perpendicular, here the two vector given, vector A and vector B. All right, and this is the theta between two vectors. All right, so we know that if this is the perpendicular, that is the height, then we know that area of triangle, it is half base, and this is the base magnitude of A into height, and height it is h. All right, I hope you understand. Half into base into height. Now this area will be half into A into h. Now my dear students, find out the value of h. We know that here the h is perpendicular and we don't have the value of this h, so try to find out the component of this one. You know that this will have the two component. One, it is the B cos theta on this axis. Let me draw. This is the B cos theta, and another component which is perpendicular to this axis, it is this one. All right, this will be the B sine theta. Okay, the two component B cos theta and B sine theta, and this is equals to this h. So we can write here this one as half times, this is area is equals to, this is area equals to half times A into H, it is B sine theta. B sine theta. Okay, my dear students. Now we can write here the half AB sine theta. And we know that AB sine theta can be written as the A cross B, but that will have the direction, unit vector also. So put this one in mod. Okay, because we know that the magnitude of that unit vector that we left here, it will be the 1. So this will be the formula of area of triangle. If two sides, suppose the vector A, it is I plus j minus k, and another vector B equals to I minus j. These two vectors are forming a triangle. Then find the area of this triangle. So you can find out the area, my dear student, half into cross product of these two. You will use determinant here easily, I, j, k. I hope you remember. Now put the coefficient. First you have to put the coefficient of A, it is 1, 1, minus 1. Now put the coefficient of B, it is 1, minus 1 and 0. And then you will have the answer. Okay. Here half into, I'm going to split it, I, alright. This is I, 0 and minus 1, all right, minus j. We know that we provide here the negative sign here, minus j. Now minus j, 0 and minus 1, and minus 1 is plus 1. Now plus k cap. So it will be the split minus 1 minus 1, minus 1 minus 1. So it is half into, we have to put here the mod, magnitude, mod. So the mod of minus I minus j minus 2k. Okay, so it will be the minus, and mod of this one will be root under minus 1 square 1, minus 1 square 1, minus 2 square 4, that is root under 6 by 2 unit square. This is the area of triangle. Okay, my dear student, in this way you can find the area of triangle. Okay, so this is the first application. I will give you the questions for your practice. Okay, let me rub this one. The next application. Now the next application, area of rectangle and parallelogram. All right, area of rectangle and parallelogram. The next application, area of parallelogram. Parallelogram. Now suppose you have been given two vectors to form a parallelogram. All right, you have been given two vectors to form parallelogram in this way. One vector and this one is another vector. If theta is the angle. All right, suppose the vector A and vector B. How you will form parallelogram? You will draw a parallel line from here, parallel to this one, and parallel line from here, parallel to this one. Now this becomes parallelogram. Okay, now how will find the area? So we know that the area of parallelogram is, yes, base into height. You remember the formula of, do you remember the area of parallelogram in geometry? You have been studied, my dear students. Okay, so here this is height h. Okay, now area will be the base itself a, the magnitude a, into height, it is h. Now the value of h, it is, again you will break the component of this b will have the two component here, B cos theta and B sin theta. Alright, so H will be the B sin theta. I can write B sin theta. So here the area will be A into B, here the capital B, B sin theta, and it is simply A cross B. But we don't have here the unit vector, so let me put in magnitude, and this is the formula for the area of parallelogram. But remember, my dear students, this is the area of parallelogram if two sides, adjacent sides, are given. All right, now suppose if you are going to find out the area of this structure, okay, this type of structure, that is the rectangle, maybe this square. All right, so what will be the area of this one? So the area will be simply, you can now write here the theta will be how much? 90 degree. Theta will be 90 degree. So you will write area is equals to simply A into B. Alright, because here the theta will be 90 degree. So the sine 90 will be 1. You will write the sine 90 will be 1. So the simply A into B. This will be the formula. Now the next one, suppose, my dear students, in this parallelogram, here when sides are given, A and B are two sides. If two diagonals are given, suppose this is the parallelogram, this one, okay, this is the side A, side B. Okay, let me draw the parallelogram. No, the sides are not given. Sorry. The diagonals are given, na? Now, diagonals are given. Suppose here the first diagonal D1 and the second diagonal, it is suppose D2. Let me write here the D2, and both are vector. All right. If diagonals are given, then how you will find here, if D1 and D2 are two diagonal. Okay. All right. Now, then what will be the area? So we know that the area, formula of area in case of this diagonal, what will be the diagonal? So look at here carefully to find the area. Okay, here you can see we are having two triangle. Okay, let me write the name A, B, C, D, and this is the O. All right, you can see clearly, my dear students, you are having two triangle, one, okay, triangle, and the second one, this one. It means we are having two, and the two similar triangle, same area triangle. So the total area we can write, my dear student, here the area will be 2 times, okay, the area of triangle. Okay, so any one triangle we will keep here. I am drawing the perpendicular of this triangle. Okay, so the perpendicular on this one will be, suppose this is, let me write, this is M. Okay, so the BM is the perpendicular. If the two sides are given, sorry, two diagonals are given, I'm very sorry, two diagonals are given, then in this case we are going to find out. Now if the two diagonals are given, suppose one diagonal is this one and the one diagonal is this one, and the angle between these two diagonals are this theta. Okay, this is the theta, the angle between two diagonal. Of course, and we find the angle between the head or tail. So one diagonal is going this way and the another diagonal is going this way. So if two diagonals are in this direction, so this is the theta between these two diagonal in this way. Okay, so this is the theta. If this will be the theta, my dear student, all right, if this is the theta, then you can see this will be, look at carefully, this will be the d1 by 2. Since this BD is d1 and BO will be the half of d1, so the half of d1. Now this d1 will have two component. One, let me draw here using my red marker, the perpendicular, like this one. Okay, this side perpendicular to this one will be this side, this one, that's it, and this both are parallel, and this is d1 by 2, and this is the theta. Okay, so this is d1 by 2 sine theta, this will be d1 by 2 sine theta, and which is equals to the bm. It means bm is d1 by 2 sine theta. Yes, we can write d1 by 2 sine theta. Now area of this triangle ABC, here the triangle ABC, it is 2 times, now we will get the total area of this structure. Area of triangle ABC, it is half into base will be d2 and height it is this one bm, which is d1 by 2 sine theta. All right, d1 by 2 sine theta. Now you can see this is 2 will be cancelled out, the half d1 d2 sine theta. Here let me write half, it is half, area equals to half d1 d2 sine theta. Okay, now the answer will be half d1 cross d2. So this is the area of parallelogram when two diagonals are given. Remember, okay, when two diagonals will be given, then in this way you can find the area of parallelogram. Okay, yes, I will give you the question for your practice. Now the next one, the last application. Let me wrap this one. Now this is the last lecture of vector analysis. We will start the kinematics. So my dear students, I'll just advise you to finish my assignment, because without doing the assignment you will not have the confidence solving the questions. Okay, here now the next application, it is the volume of parallelepiped. What does this shape of the parallelepiped, my dear student? Here, cuboid. If you will make a cuboid, if you're having a rubber cube or cuboid, if you will press that, okay, to the one side, then you will see it is tilted. So that tilted shape of cuboid is considered the parallelepiped. I am drawing here. This is a very important engineering structure. It is called parallelepiped. Okay, this is the structure of parallelepiped. Now the one axis, it is this one along this side, x-axis, along this side it is z-axis, and this side it is y-axis. All right, my dear student, here the three vectors are given in this way. Actually this y is upward, in upward direction, since your structure is tilted by some angle. All right, now the three vectors are given, 1, 2 and 3. Okay, so the vector A, suppose the three sides are given B and vector C. Now you have to find the volume. Okay, so I'm sure that if you understand, finding the area of this particular base, okay, this particular base, and multiplying with the height, okay, you will get the volume of this structure in this way. Okay, my dear students, now look at here. So the volume we will obtain by cross product of any two sides, either C cross B, either A cross B, either B cross C. Okay, any two vector, any two side, do the cross product. So the A cross B, and suppose here the angle it is given theta. All right, A cross B, and thus A cross B, you will get the area of this side, A cross B, simply. And when you will multiply with this side, okay, C, you will get the volume. So dot C. Okay, you can see this is the scalar triple product. It means the scalar triple product of three consequent sides of a cuboid gives the volume of parallelopipe. This is very important. Okay, my dear students, so must remember. So the volume will be, the formula of volume will be this one. Okay, now I'm going to give you some homework. So these are the formula that you must remember. The area of triangle, okay, what it was half into mod of A cross B, that is the two sides of a triangle. Then area of parallelogram or the rectangle, if sides are given, consequent sides are given, then we have studied the area. Then if diagonals are given, the sides are given, then we have studied the mod of A cross B. A and B are the two sides of a parallelogram or the rectangle. Now in case of area of parallelogram, if diagonals are given, then we have studied half D1 cross D2 and the volume A cross B dot C. Remember, you can write also B cross C dot A. You can also write A cross C dot B. Okay, so by all the three formula you will get the same answer. There will be no fluctuation in answer, believe me. Okay, you will do at your home. Now homework, let me rub this. The first homework is a triangle. It is two vector A and B making triangle A and B. Okay, you have to find the triangle. The vectors are 2i minus 3j, and the B, it is I minus 2j minus 3. Okay, all right, you have to find area. Find area of triangle. Second question, A, it is 3k, B, it is 2i minus 2k, C, it is I minus j plus k, D, it is I plus j plus k. Okay, now in this second question, question A, find area of triangle made by vector A and D. Okay, B, find area of triangle made by vector C and B. Okay, in C, area of triangle, find area of, Okay, parallelogram, area of parallelogram, if A and C are two sides. Okay, D, volume of parallelepiped if A, C and D are three sides. Okay, then you have to find volume of parallelepiped if A, C and D are three sides. Okay, so these are your homework. So we are concluding today the chapter vector analysis, my dear student. From next lecture I will teach you kinematics. We will start one-dimensional kinematics and then we will proceed further. We will also study in next class that this kinematics have been break in different parts. Okay, my dear student. So this is all about today's lecture. Thank you very much.